Hello, everyone. My name is Mr. Minnick. Some people call me uh, the Space Cowboy, and some people call me the Gangster of Love. Some people call me the Math Overlord. But anyway, today we're talking about an introduction to probability. We're going to be talking about counting methods. So if you want a quick road path of where we're going, we're going to be talking about the following items. We're going to talk about N. Why did I say it so loud? Well, because there's an exclamation point after it. What's that mean? It means N! What's that mean? I don't know. We'll see. So we're going to be talking about that. We're going to talk about subscript N, capital P, subscript R. Subscripts, if you're not familiar with them, they're like superscripts, but kind of the opposite. They're written next to, but slightly below and slightly smaller. So that's sub N, capital P, sub R. We're going to talk about that. Same idea with the C instead of a P. That's sub N, capital C, sub R. We're going to be talking about that. And we're also going to be talking about the General. For the best car insurance rates in town, call 1-800-GENERAL now. Town and now don't rhyme, do they? For the best car insurance rates in town, call 1-800-GENERAL now. So the general counting rule. Okay? Along the way, we're going to be looking at how to use the calculator to do this. We're going to find a really cool way to do one of these without a calculator. So that's where we're heading. This is just kind of like an overview, a row pass, like an outline. So if you're writing any of that down, you might want to leave some space in between them. So the first thing we're going to do is start off with an example that goes like this. Example 1, how many ways can we arrange the letters, the following letters? So we're going to be arranging some letters. You ready for this? The letters are E, S, and X. Okay? How many different ways can we arrange those letters? Now, to answer this, some people like to start arranging them. So they do this. So here's the first arrangement, just in that order, ESX. The second arrangement is EXS. And then the third arrangement, if we start with a new letter, let's try starting with X this time. We have XES. Let's try starting with a different letter this time. Still with X. So XSE. So there's 4. This time we'll start with the letter S. SXE. So there are 5 ways to arrange those 3 letters. Right? What's so funny? What's so funny? Is there another way? Oh, there's 6. Okay, you're right. You're right. So there is a 6th way. I'm not going to write it, but there are 6 ways to arrange those 3 letters, right? Well, let's try this again. So we'll call that example 1 part A. Let's go to example 1 part B. Example 1B. How many ways can we arrange these letters? This time we'll go with H, I, T, and S. H, I, T, and S. Okay? So we'll start with the letter H. I guess that's a nice place to start. So we got H, I, T, S. Then we got H, I, S, T. And then we got H. Let's start with S now. So H, S, I, T, H, S, T, I. And then H, T, I, S, and H, T, S, I. So there's 1, 2, 3, 4, 5, 6. So it seems like when we started with the letter H, there were 6 ways. Let's start with another letter this time. This time, let's start with the letter I. I, H, S, T. I, H, T, S. I, T, H, S. ITSH, I S HT, and ISTH. So there's 7, 8, 9, 10, 11. So far we got 12. Now you might be able to guess how many based on that, but let's continue. So this time we'll start with the letter T. T, ISH. I was telling my other class that I actually had my first crush ever on when I was in 7th grade. I was in track, and there was a senior who high jumped. She jumped like 5'6". Her name was Tish. So anyways, not that you wanted to know that. TISH, and then TSIH, and TSHI. So now we got to start with TH, THSI, and THIS. Hey, it's this. So there's 13, 14, 15, 16, 17, 18. And again, you might be able to speculate, but let's finish this. So now we start with STIH, STHI. Let's go SI, TH, Sith. Isn't that something from Star Wars or something? Okay, I thought so. And then we got SIHT, and then we got SHTI. So there's 19, 20, 21, 22, 23 ways. 23 ways. There's 24? Okay. So with three it was 6. With 4 it's 24. Do we want to try this? Do we want to try this with 5 letters, or is it going to take too long? It's going to take too long. There's got to be a way to figure this out. In my first period class, somebody brought his A game and said, "Oh, I know. We just do blah 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 blah." And everybody's like, "What? What was that all about?" Does anyone know how we could calculate this quickly? Can't you just write them all out? That's going to take a long time to write them all out. It's going to take a long time to write them all out. Well, I bet there's an answer somewhere in the notes, somewhere where we're going to go. I bet there's an answer. Seeking words of wisdom, let it be. Let it be. When I find myself in times of trouble, Mother Mary comes to me, seeking words of wisdom. Let N be. Let N be any natural number. Then we can arrange n items in number of ways. The formula is as follows. N equals. Does anyone have any idea what N equals? N is any natural number. We can arrange n items in factorial number of ways. The formula is this. N factorial equals n times n minus 1 times n minus 2 times. I don't like the way textbooks do this, but I'm going to show you the textbook way just because I don't want to give away an answer that's going to come up later. Multiplied by 2, multiplied by 1. That's what every single textbook will show you, that n equals. There is a word that starts with the letter F that these are all about. Anybody know what this is called? I thought somebody said it. Starts with an F. These are called Factorials. Okay, so n with an exclamation point is read as n factorial, n factorial, n factorial. So if we go back to our example 1 part A, example 1A, we had 3 letters, right? There's a question, what's the deal with these 3 dots right here? The 3 dots here means that's an ellipsis and that pattern continues. So you start by however many things there are that you're arranging. You multiply by 1 less than that, then by 1 less than that, then by 1 less than that. And it depends on how many things there are in the first place, but you ultimately multiply in the end by 2 and then by 1. So it just means that pattern continues. We could have written n minus 3 and n minus 4, and then on the other side of that, 4 times 3 times 2 times 1. Okay, it just means that that pattern kind of continues. So again, if we go back to our first example, how many ways can you arrange 3 letters? Well, the answer is simple. It's 3 factorial. By the formula, we take 3, which is a natural number, and we multiply 3 by 1 less than 3. Well, what's 1 less than 3? 2. And what's 1 less than 2? And 1 is at the end of that sequence. It's at the end of that formula. So 3 times 2 times 1 equals the 6 ways. Good. How we doing? That's it. So example 1B, we had 4 letters, right? We had 4 letters. So this would be 4 factorial. 4 is our n. It's how many things we're arranging. So we've got 4 times 1 less than 4. So times 3. Times 1 less than 3. And times 1 less than 2, 1. And 4 times 3 times 2 times 1 is 23. 24. We doing okay so far? This step's really not that difficult. It's pretty logical, pretty sensible. However, there is one enigmatic thing that shouldn't come up, but it does. It always comes up. We shouldn't even talk about it. An enigma. Does anybody know what that word means? It's Logan Steiner who wrecked Parker Recchi in the Wyndham game freshman year. Shout out to Logan Steiner. No, what's the definition of enigma? What's that mean? Can't explain it, you don't know, something like that. So, 0! That is an enigma. First of all, we shouldn't even be talking about 0! Who can explain why we shouldn't be talking about 0 if you look at the definition? Because you can't go any farther? Kind of-ish, but look at the definition. The definition starts off by saying, Mother Mary comes to me in times of trouble. Let n be what? Let n be what? Any natural number. The first week of school we talked about natural numbers. What's the first natural number? 1. So is 0 a natural number? No, it's not. So by definition, we shouldn't even consider 0 factorial. I told you the way most textbooks write this, I don't like it. The way I write the final part of this formula is I write it as n minus the quantity of n minus 1. People don't like it when I write it like that, but it makes a lot of sense. What would happen if you plugged in a 0 into that n minus 1? What would you get? 0 minus 0 minus 1. What would you get when you evaluate that? Let's evaluate it and see what we get. We get 0 minus negative 1. So we get minus negative 1. So what do we get? 1. The answer, what 0 factorial is, it equals 1. And people say, well, that doesn't make any sense. It should equal 0. Well, think about it this way. How many ways can you arrange nothing? There's one way to arrange nothing. You can't. You don't arrange it. It doesn't make sense to arrange it. That's why it's enigmatic, and that's why we shouldn't even talk about it in the first place. But 0 factorial is equal to 1. all day, every day. So before we move on, I probably ought to show you where to find factorial on both calculators. Keep in mind the TI-30 and the TI-83 do this the exact same way. A lot of the stuff. So we'll start with the Inspire. The TI Inspire from a calculator page. Let's find 5 factorial, 5. And it drives me nuts when I see people do this on these calculators. The calculator has a button to do this. The calculator has built-in ways of doing this. You just go 5. Does anyone know where the factorial button is, or the exclamation point might be? When in doubt, press menu, but that's going to take too long. Menu, what are we talking about? Probability. So we're going to go to probability. And there it is, factorial, bam, 5 factorial. Another way to bring that up is to press the button next to the G's, not the hustlers, but the G's. The button next to the G, right there. So you put in the number, and on the Inspire, you press the probability menu and probability. But on the Inspire, the button next to the G has all kind of cool stuff like that right there. Okay. On the TI-83 and the TI-30s, again, we said we're talking about probability. Probability is a mathematical topic, right? So what button do you think I want to press? If it's a math topic. Math. We're not talking about math. We're not talking about number math. We're not talking about complex numbers. We're talking about probability. Check it out. 5 factorial is 120. Who's taking stats next year? Anybody? If you are, we're going to find all kind of factorials. Let's find 8, 10, 4, and 5 factorial all at the same time. Check this out. Do you see how I used some little braces in there? I put 8, 10, 4, and 5 in a list, and then I'm going to bring up the factorial, and it'll find all those for me instantaneously. Check it out. You like that? You can do that on the Inspire too. So we're going to be using lists quite extensively in stats class. So any questions, comments, concerns before we move on? Okay. Well, I think we've talked about factorials, all we need to talk about them. So this next thing we're going to talk about picking. They say you can pick your nose. They say you can pick your friends. But I think whoever they are, they say don't pick your friend's nose. So anyways, these next 2 ideas are all about picking. The variable n represents how many there are to pick from. I hate ending a sentence in a preposition. My English teachers used to give me a hard time for that. N is how many things there are to pick from. The variable r is how many things we pick. Technically, n and r should be natural numbers, but again, some textbooks, some math problem sets, they ask you, well, don't pick anything. And technically, you shouldn't be talking about not picking anything because there's only one way to not pick anything. You don't. So anyways, n and r are natural numbers. And there's 2 formulas. One is all about permutations. Permutations. And the formula goes like this. Sub n, capital P, sub r equals. This formula is kind of scary, but it's not so bad. It's n with an exclamation point, that's n factorial, divided by, and it's real important, people leave out parentheses. If you leave out parentheses, it's so wrong. So wrong to leave out the parentheses. We need to quantify n minus r, the quantity factorial. With factorials, people want to look for shortcuts. They want to simplify and reduce factorials. You can't reduce a factorial, but you can reduce after you factorialize it, if that makes sense. So there's permutations, and that's the formula for them. The other one is called combinations. Combinations. And the formula for that goes like this. Sub n capital C sub r is n factorial over the quantity n minus r, the quantity factorial times r factorial. And you might say they're the exact same thing. Well, no, they're not. They look identical. No, they're not identical. There's one difference between the two. It's a real subtle difference, but it is a difference. How's everybody doing so far, okay? Well, let's see these two things in action. And we're going to put these in action side by side just to kind of see how these compare. I guess what I'll do is I'll go split screen. Split screen. Let's find 7, choose 3. I want to start with the P's, I'm sorry for that. I'll start with 7, P3. Over here we'll do 7, C3. After we pick 3, I guess it makes sense to pick 7. Let's pick 5. We'll go 7, pick 0. 7, pick 1. Let that 5, I'm going to make it a 6. I'm sorry about that. I'm going to make it a 6. And we'll go 7, pick 7. Okay, so we're going to evaluate all these. And a couple of them we'll do without a calculator, and then we'll throw the calculator in the mix after we get a couple of them out the way. So we're going to do the same thing with combinations. 7, choose 6. 7, choose 0. 7, choose 1. And 7, choose 7. Okay. We ready for this? So for permutations, we said it's n factorial. So this is 7 factorial over the quantity. 7 minus 3, the quantity factorial. Don't cancel factorials. Once you factorialize it, then you can cancel. So this is 7 factorial over 4 factorial. So that's 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 4 times 3 times 2 times 1. Can anything there cancel? Four, 3, 2, 1's all going to cancel. 4 times 3 times 2 times 1 in the denominator cancels 4 times 3 times 2 times 1 in the numerator. So we've got 7 times 6 times 5. 6 times 5 is 30. And 3 times 7 is 21. So I think this is going to be 210, huh? It's looking like 210. 210. Okay. Everybody follow that one? Questions, comments, concerns, short debates? 210. It ends up being 7 times 6 times 5. So let's go to the combination one. The combination is going to be 7 factorial over 7 minus 3, the quantity factorial, times 3 factorial. So that's 7 factorial over 4 factorial, 3 factorial. That's 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1 times 3 times 2 times 1. Whoa. Wow. This one's kind of tricky how things cancel. 3 times 2 times 1 cancels 3 times 2 times 1. The 4's cancel, so 4 cancels 4. Hey, wait a minute, isn't 3 times 2 really 6? We can't get a 2 for 1 on this. You got to be careful doing this. But 2 times 3 is 6, so this 2 times 3 cancels out that 6 up top. What's left? 7 times 5. What's that going to give us? Yeah, let's go single screen on this. So what's this end up equaling then? 7 times 5 is 7 times 5 is 35. How's everybody doing, all right? Got good news and bad news. Good news is the calculator does these. Bad news is I'm going to have to do some of these without a calculator. I'll make it bigger in just 1 second. What's bigger, a permutation or a combination? A permutation. How much bigger? It's an interesting story how much bigger it is. That'd make a nice essay question. How many times bigger is a permutation than a combination? How many times bigger? In that case, it's 6. 6 is 3 factorial, isn't it? 3 was r. It's r factorial times bigger. Question is, where did the denominator come from? If we look at the denominator, let me get my highlighter going. I said the highlighter going. In the denominator, 7 minus 3, the quantity factorial, simplifies to be 4 factorial, which, if you remember the factorial formula, it's 4 times 3 times 2 times 1. So that's where that comes from. The formula for combination says we also need to put an r factorial in the denominator. So we get a 3 factorial in the denominator, and that's where that other 3 times 2 times 1 comes from. Okay? So when we canceled this, what happens is this 4, 3, 2, and 1 canceled this 4, 3, 2, and 1. And then 3 times 2 is really 6. 3 times 2 is really 6, so like this 3 times 2 kind of cancels out with that 6. So the only thing that ends up being left is 7 times 5, and that one's 35. Okay. R factorial times bigger. A permutation is R factorial times bigger than a combination. So real quick, while we're here, let's go ahead and crank out a few more of these. 7 choose 6 would be 7 factorial over 7 minus 6, the quantity factorial, times 6 factorial. That's 7 factorial over 1 factorial times 6 factorial. That's 7 factorial over 6 factorial. This is so cool what happens. Watch. It's 7 times 6 times 5 times 4 times 3 times 2 times 1 over 6 times 5 times 4 times 3 times 2 times 1. What all cancels? Dang near everything, doesn't it? All of it besides the 7. So 7 choose 6 is going to be 7. Like that? So 7 choose 6 ends up being 7. What happens if we choose nothing? What happens if we don't choose anything? Here we're going to get 7 factorial over 7 minus 0, the quantity factorial, times 7 factorial. No. Times 0 factorial. That's 7 factorial over 7 factorial times 0 factorial. That's 7 factorial over 7 factorial. What's something divided by itself? Something divided by itself is 1. Huh. This is kind of interesting what happens on these. 7 choose 1 is 7 factorial over 7 minus 1, the quantity factorial, times 1 factorial. That's 7 factorial over 6 factorial times 1 factorial. That's 7 times 6 times 5 times 4 times 3 times 2 times 1 over 6 times 5 times 4 times 3 times 2 times 1 times 1. Everything cancels. It's 7. Well, almost everything cancels. This is kind of weird, isn't it? Anybody know what 7 choose 7 would be? 7 choose 7. 7 factorial over 7 minus 7, the quantity factorial times 7 factorial. 7 factorial over 0 factorial, 7 factorial. That's 1. So what's really weird, you might want to make note of this somewhere. N in general. N choose n is the same as n choose 0, and that's always equal to 1. Okay? That's a general case for combinations. It always works. If you choose all of them, if you choose none of them, it's always equal to 1. On a similar idea, on the similar token, n choose 1 less than n is the same thing as n choose just 1. Whoa, where'd that circle come from? Will the circle be unbroken? N choose just 1 is always equal to n. Those will always work. Those are general cases for combinations. I smell a concept quiz next week sometime over permutations. How much bigger is a permutation than a combination? R factorial times bigger. N choose n and n choose 1 are always equal to 1. Okay. Well, let's go back and pick up a couple of these. 7 permutation 6. This is 7 factorial over 7 minus 6 the quantity factorial. This is 7 factorial over 1 factorial. Isn't that just going to be 7 factorial? 7 times 6 times 5 times 4 times 3 times 2 times 1 over 1. 7 factorial is big. Anybody got it? Anybody got a calculator handy? I know 6 factorial is 120. So it's 120 times 7. Is it 840 or something like that? $540. Thank you. Good looking out. $540. So one thing you might want to jot down if you're writing down these general cases is this. 7 choose, not 7, sorry, n. N choose, yeah, question, comment? 5,040, okay. I thought 540 seemed a little small. Okay, so if we have n items, and I'm writing the wrong thing here, let's just call time out and start over. Maybe I should pause for shout outs. Maybe I should give a shout out to the future Mr. Minnick. Maybe I should give a shout out to Craig Jones. Maybe I should give a shout out to Katie Fairby. Maybe I should give a shout out to Mariah Bly. Or maybe Alexis Z. Is she here today? Okay. So if we have n items and we permute them n minus 1 ways, that's always going to equal just n factorial. That's kind of weird. Do you want to see how to do this on the TI calculators? This is going to be so much easier. So much easier. We've been really kind of spending a lot of time doing this without the calculator. Watch this. On the 83 and the 30, you got to put n in first. You've got to put n in first. 7. So where did we go to get the factorial? Where do we go to get the factorial? Math, thank you. And then probability. So here's my permutation. 7 permuted 6 ways is 5,040. 7 permuted 0 ways is 1. So here's another general case for us. Another general case. N permutation 0 is always equal to 1. N permutation 0 is always equal to 1. Let's try this next one on the Inspire. The Inspire works totally different than the 30. Check it out. Write it down. I want 7 permuted 1 way. I'm going to type in NPR. I'm just typing in NPR. That's it on the Inspire. NPR, parenthesis, 7, 1. There we go. So that ends up being 7. Yeah, just hit enter after that. There is another way on the Inspire to bring that up. So in general, NP1 is N. Okay. Finally, on the Inspire, another way to do this is go menu. I said menu, probability. There's permutations, and you put in 7 and 7. We get 5,040. So here we get 5,040. So NPN is also in factorial. In an Inspire, you type in NPR or NCR, and then you put in N, and then comma, and then R. Are there any questions, comments, concerns, short debates, long debates about how to use either calculator to calculate either of those? The TI-30s do this just like the 83 does. You got to put N in first, and then you hit the PRB button, and they're right there. Good question. Well, we still got several ideas to talk about. The next one is this. Permutations, by definition, are arrangements. By definition, permutations are arrangements of n objects picked R at a time. Example, 70 people run a race. How many ways could the top 3 be picked? 70 people run a race. How many ways could the top 3 be picked? What they're telling you here is, hey, because they're running a race, because in a race order matters, because it's an arrangement, you're going to use a permutation. You're going to use a permutation. What's my N in this problem? 70. And what's my R? 3. So I'm going 70, P3. So either calculator I use doesn't really matter. Let me use my TI-83 on this one. 70, math, permutation, choose 3 of them, and I get 328,440. 328,440. How's everybody doing, all right? Let's look at one more example here before we move on to the last idea for today. Example. Of 120 sophomores, we're gonna pick 5 class reps. How many possible ways can we pick How many possible ways can we pick them? Now you got to think about something here. There was a key word that I talked about with permutations. Permutations was an arrangement, right? If we're talking about class representatives, is one class representative, in theory, more significant than another? Or are they all on the same level, so to speak? Somebody said it? They're all on the same level. So it doesn't matter what order we pick class representatives in. And this is where you have to pick this on your own. I am not going to help you when it comes to the exercises. I'll say, does order matter? And that's all I'm going to say. So does order matter when we pick class reps? No, it doesn't. So what are we going to use? A permutation? Nope. We're going to use a combination. By definition, with a permutation, it's an arrangement. If we're picking people that finish a race, we care who gets first, because the person that gets first gets a better prize. When we're picking class officers, it doesn't, if you're a class officer, it doesn't matter if you were picked first or last, you're a class officer. So the order doesn't matter. Okay, good question. So here we're going to take 120, and we're picking them, picking 5 of them. So again, with the Inspire, you can just type in NCR, parenthesis, 120, pick 5, 120, pick 5, and there we go. Okay. One final thing we're talking about today, the answer's a lot. 190,578,024. Really doesn't matter. Well, it does kind of matter, but. This is kind of cool. The interesting thing about Pascal's triangle, you might see it up on the little painting in my room. What this one right here represents is 4, choose 0. What this one on the end represents is 4, choose 4. So you might want to know this because at some point you're going to have to calculate combinations without a calculator. So what's 4, choose 1 equal to? What would 4, choose 1 equal? 4. What about 4, choose 2? What about 3, choose 1? 3, choose 1 would be 3. If we continue this triangle, we would have a 1 and a 5 and a 10 and a 10 and a 5 and a 1. What would 5 choose? What would 5 choose 2 be? 5 choose 2 would be 5 choose 2. Here's 5 choose none. Here's 5 choose 1. What would 5 choose 2 be? How do you figure that out? Noticing patterns in mathematics. I figured that out from chapter 9 in Algebra 2. It's called binomial expansions. Okay? So the final idea we need to talk about today is this. The general counting rule. The general counting rule. It says if there are x ways, if there are x ways to choose one thing, the first item. If there are x ways to choose the first item and y ways to choose the next, comma, then there are x times y, getting ahead of myself, x times y ways to choose both. On the OGT, on the ACT, on the SAT, they always have this question. You're going to buy lunch. There's 2 drink choices. There's 3 sandwich choices. There's 2 dessert choices. How many possible lunches are there? Let's try that again. The first item. X ways to choose the first item, Y ways to choose the next. Then there are X times Y ways to choose both. So again, with the school lunch, there's 2 drink choices, there are 3 sandwich choices, and there's 2 dessert choices. How many possible school lunches are there? 12. Okay. So the final example we're going to look at, we're going to go into somebody's wardrobe closet. Everybody always says, I don't have anything to wear. I have nothing to wear. We'll assume that an outfit consists of pants, socks, shoes, a shirt, an undergarment, and we'll just go with that. Pants, socks, shoes, shirt, and an undergarment. You know what? Let's make this, no offense to the female gender, but women, my wife always says, I don't have anything to wear, and she buys clothes every day. So we'll say underwear 1 and underwear 2. Okay? So let's go into my wife's closet and find out what we have. My wife has 8 pairs of nice blingy pants that fit her. She has, I actually stole most of her socks, but she has about 12 pair of socks. Okay. My wife has about 8 good pair of shoes that don't stink, that are nice. Shirts, my wife has about maybe 20 shirts. Underwear, 1, I wash her underwear. I go to the laundromat and do this. I know she has 5 really good bras and about enough to make it through a month and a half, so probably about 50 of the other. Okay? I have nothing to wear. Nothing to wear. How big of a number do you think we're going to be looking here? Who thinks it's going to be in the millions? Don't have anything to wear. I only got 8 pairs of pants. Poor me. Poor me. Here we go. The counting principle says let's multiply. 8 pairs of pants, 12 pairs of socks, 8 pairs of shoes, 20 shirts, 50 of the first undergarment, 5 of, oh, there's one thing I forgot. Earrings. Right? Because let's face it, ladies, isn't that part of an outfit? Earrings. My wife's got 4 pairs of earrings that she wears on a regular basis. So let's see. Times 4. I don't have anything to wear. I have 15 million different outfits, but I don't have anything to wear. It's been real. It's been fun. I hope that you understand the introduction to probability. One last thing I'll leave you with. I know I said we had one last topic. This will help you get through 11.1. What's the probability of getting a number 2 on an even number cube? What's the probability of the number 2 coming up if you roll a number cube? A dice. There are 6 possible numbers. What's the probability of 2 coming up on it? 1 in 6th. As a decimal, that's 0.166666666. To 3 decimal places, what is that? To 3 decimal places, that would be 0.1 to 3 decimal places. 0.167. You could do 11.1 homework now. Have a great day.